Hello and welcome to another tutorial. In this tutorial, we're going to continue our discussion on operators in Java, and we've looked at the assignment operator, arithmetic operators. Now let's look at the unary operators. The meaning of a unary operator is that it only acts on one operand. And we saw that binary operators, like arithmetic ones, they operate on two operands. And the way these operators works is they have some operands. The operands can be a literal or any variable or expression, and these operands first get evaluated, and then the result is passed to the operator. So if you have expressions as an operand of a unary operator, that expression gets evaluated first, and then the result is passed to the operator, and the unary operator acts on that operand. The unary operators require only one operand. They perform various operations such as incrementing, decrementing a value by one, and obviously plus plus and minus minus, these are the famous ones, and C++ also support these. Negating an expression, this exclamation mark is a logical negation. It acts on an expression that returns a Boolean type, like and then inverting the value of a Boolean. So a negation or inverting the value of Boolean, and then so plus minus, these are mathematical operators. They act on numeric values or expressions that return a numeric type, and then these basically plus, we don't normally use this because if you have a number, let's say 2.5, you can also just write 2.5 or plus 2.5 is the same. And unary plus operator indicates positive value. Numbers are positive without this, however. That's why the default assumption is that the plus is not necessary. So let's create a new class, unary operators. Let's have a main method, and in the main method I'm going to have a test1, and let's have a static method, public static void test1. And we're going to look at the plus unary operator. We say that let's say int x1 is 5 and int x2 is plus x1. This is fine, and we normally don't, for numbers like plus or negative 5 or plus 5, we don't usually use the plus unary operator because it doesn't really have any effect. So this plus doesn't really have any effect. That's because it's the default anyways, right? It's the default anyways. So plus is not really something that we use that much because it's the default. However, negation is something that we typically use with the let's add the semicolon here. With the numeric expression, negation is a minus unary operator, right? So minus, you put it before a expression that returns a numeric type or before a variable that holds a numeric type, and then it negates the value. And it's a mathematical negation, not a bitwise negation, right? We saw that if you use tilde, for example, that's a bitwise it flips the bits. But negation is just negate or changes the sign bit, right? So int x3 is minus x1. What we're doing is that we are changing the sign. So if I obviously do a sysout on x3, we get negative 5. Yes, negative 5. And I think it's also good to look at the bits. So x1 equals 5 in bits. Let's do arrow plus integer to hex a string and then x1. We saw that integer class has this utility method, which is a static method to hex a string. It returns the bits, or let's instead of hex, let's say yeah, I mean, we can look at the hex first and then x3. We already saw about how Java handles the sign integers, signed integers in the previous lectures. It's just it uses a 2's complement representation. The last bit or the leftmost bit is reserved for the basically for the sign bit, right? So minus 5 is So so 5 in bits is 5, obviously, because so the hex representation of 5 is remember integer is let me just write it down here. Integer is 4 bytes in Java. That's the strong guarantees 4 bytes. So 5 becomes so 0 hex, right? Each byte is 2 hex. So 0 0, that's 1 byte, and then 0 0 2 bytes, 0 0 3 bytes, right? 8 bits is and then 0 5. That's the hex representation, which when you use 2 hex string, it just uses 5, right? And then what happens when we have -5? Now we have to go 2's complement. So we flip the bits. So 0 becomes F, all zeros becomes 1. So 2F here, 1 byte, 2F here, 2 bytes. And then another one, 3. And then 0 5 becomes F, and then 5. 16 becomes 11. So A is 10, is B is 11, something like that. So that's why we're getting this hex representation. And then we can also look at the basically, let's see, to binary a string. So let's also look at the bits. And 101, obviously in base 2, this means 1 plus 2, 0 times 2 plus 1 times 4. This is 5, correct? So in binary, it's basically 101 in base 2, right? Obviously this is 32 bits, so we have lots of more bits here. 4, and then 4, 8, and then 12, or let's go with 8. So this is 8 bits, and then 16 bits, and then 24 bits, and then so it should be something like this, 32-bit integer. When you use this 2 binary string, it only keeps the bits from the right side until it hits all the zeros. So it doesn't show all the zeros, right? And now when we do basically 2's complement or negative numbers, as you can see, we are flipping all the bits, right? And then it becomes 1 0 1 0, right? And the last 4 bits here, 1 0 1 0. So we flip all the bits to, and then this -1, this last bit means it's a negative number. Now the reason we're using 2's complement obviously is because how to represent 0, right? 0, if you don't use 2's complement, then you end up with 2 values for 0, which is a waste. That's why they use 2's complement. If you're not familiar with 2's complement, you can refer to my previous lectures, or you can just Google it to see how 2's complement system works, right? So signed integers is 2's complement in Java. All right, and then so plus negation, and then we saw previously in our circular buffer class, or where did we use the assignment operator? So we had this vector 2D. So I'm going to copy this here. Let's put it outside. Now it's the same package, vector 2D. Let's call it vector 2D 1. I want it to have different name. We already overloaded the assignment operator, and now we want to also overload the unary operators. So Java, the operator overloading plugin for Eclipse, operator overloading plugin for Eclipse supports negation unary operator, right? So we say public, and then remember, negation is not static, right? You want to change read the state of the current object and return a new object that whose value is negation the way you define it. So vector 2D, when we negate it, we just want to negate the 2 fields x and y. So public, we're going to return this vector 2D type, and then negate, right? So the name of the method is negate, and then we don't get anything because this is going to read the state and then return new vector 2D1, and we're going to get -x, So we read the state and return a new object that logically negates the state of this vector 2D. The way we define it for a vector, which is a mathematical object, obviously we just take its elements and negate them. So if I want to test this, so public static void test2. So var v1 is a new vector 2D 1, and then 1.1 2.2, and then var v2 is minus v1, right? And this works because Eclipse IDE, the way this works is that the plugin, so Eclipse plugin for vector for operator overloading, when it sees the assignment operator, it tries to evaluate the right hand side, and then it already knows that the type of v1 is vector 2d1. So Eclipse compiler goes there and tries to see if it can find a method called negate, and when it can't find it, it just translates this in bytecode. It actually writes v1.negate, and we know that this returns a type of vector 2d1. So this is just the meaning of operator overloading. Java doesn't support it, but Eclipse IDE has a plugin that supports this. And we already so let's do a sysout v1 and then sysout v2. Let's confirm that. Remember, we have the toString method for this vector 2D. Yeah, so we are calling the constructors, and then let me remove the call to the constructors. That's not necessary in this case. All right. So we're going to see, so vector 2D, we create one new vector 2D, and then we overloaded the negation operator, which is a unary operator. Note that Eclipse, this plugin for Eclipse doesn't support plus, because really we don't need to use plus v1, it's just v1, right? But then we're going to use minus v1. So this works. We get minus 1.1, minus 2.2, and remember that when you negate, the contract is you're not going to change the state of the current object. Instead, you're going to create or return a new object, right? And then now obviously we also overloaded the plus operator, which was a binary operator. So if I say v2 plus v1 and do a sysout v3, obviously we're going to get 0 0. And the reason this doesn't work because we forgot to this class currently doesn't have the add overload. So public vector 2d1 and add vector 2d1 other, and then return new. Let's just quickly add this overload, new vector 2d, and then x plus other dot x, and then y plus other dot y. So we just overloaded the plus operator, and now this works. Eclipse quickly compiles and then binds this call to the add method inside the vector 2D class. If we run this, we get 0 0 as expected. So this is very handy if you're doing math in Java, and Eclipse plugin for operator overloading supports these nice features. And lastly, I want to just show you this. Let's look at the bytecode to make sure that nothing out of the ordinary happens. All these operator overloading, the meaning is that the compiler binds these operators minus v1. v1 is a user defined type. It's a vector 2d1 type. This is not a built-in type in Java. And all the compiler does is just translates this in bytecode to a call to a method, and we can confirm this. So if I look at test2 here, test2, we're calling the new operator and then vector 2D, and then load const wide. So we're using a wide floating point, which is wide means it's a 64-bit, right? 1.1. These are double literals. So I remember a stack in Java is 32-bit. That was admittedly a mistake. I mean, it wasn't a mistake when they actually wrote down the Java language specification, because at that time processors were mostly 32-bit, but these days processors are 64-bit, but the Java stack is also works as 32-bit. So loading a double, which is a 64-bit, is not an atomic operation. It requires two basically instructions to actually load the 64-bit into a 32-bit stack in Java. But we're loading a 1.1 double literal and then 2.2 double literal. And then invoke a special means call a special method. What is that method? Obviously, it's constructor. Constructor is just a special method that takes double double, right? This is what the new operator works. And then a store 0 means store the address of an object. A, when you say a store, it means we're storing the address of an object. If you say I store, means store an integer or address to an integer, and it's an integer variable. A store means it's a variable pointing to an object, which means it's a reference type or pointer type. And then a load. So this first line ends here at line 13. We create the object and then we store it in one. And now the second one, we first have to load v1 again. That's why we get a load, which means load a variable that is a reference to an object. And then we're going to negate it, and that's where the operator overloading comes into place. And the way what the Eclipse compiler did using this plugin, operator plugin, was that replace this with a call to the negate operator. Invoke virtual means call a method. What is that method? Negate from vector to d1, right? So that's the meaning of operator overloading, and it doesn't take any parameter and returns a vector 2D type. And the types are compatible, and we saw that var automatically deduces the type, so this var becomes handy here. All right, so we invoke, we create this, and then remember, assignment operator, anything on the right hand side must be evaluated first, and then the result is assigned to the left hand side, and the types either have to match or there is the implicit conversion must be possible. So for example, if the negate method in v1 is in the vector 2d1 class returns a type that is not exactly the same, then we might run into a problem. Now the nice thing about var is that we don't run into a problem if we use var, because if later on and you go and you change the behavior of the negate method, var automatically deduces the new type. As long as the types are compatible, your code still works fine. Now obviously var only works in the context of local variables, so you cannot use it for class fields, for example. But this is a very nice thing to have, that for example later on maybe I subclass the vector 2d1 and override the negate in the subclass, and then if I use a subclass and this works, then var automatically deduces the correct type, for example, right? But the whole point here to show you how the operator overloading works with the unary operator like negation, it just maps it to the call to the method negate. And then we're printing, and then this line, this is where we calculate v3, which is v2 plus v1. So it loads the variable v2, the address of that this variable v2 holds, which is address of an object. It starts with a. So we load v2 v1, and then the Eclipse compiler basically in the bytecode it routes this to a call to basically v2.add v1. So it translated into the bytecode. We actually write this call to this add method, and you see it's a method, right? Invoke virtual, and add takes a vector 2d1 and returns a vector 2d1. So operator overloading is nothing magical. It's just the bytecode is exactly the same as if you wrote it manually with the call to the method add, but it's just a nicer way in the source code to represent things. So I hope you enjoyed this lecture. Let's see if there's anything remaining from the unary operators. The not operator, plus plus minus minus, these are easily understood. I believe Eclipse plugin for operator overloading doesn't support overloading these two. Of course in C++ you can also overload any of these operators. The following program, unary demo, tests the unary operators. So result equals +1. Remember, assignment operator, anything on the right hand side will be evaluated first, and then the result is assigned to the left, and the types must be compatible. +1 is not necessary. Result minus minus. So the way this works is that, remember, these unary operators, plus and minus, they have return values. These are operators. Any operator has a return value. And the way this works is that if you use the postfix notation, put the plus plus or minus minus after that, basically what happens here is that it acts on the current variable and reduces it by one, but then it returns the previous value. Same for plus plus. If you use the prefix notation, say minus minus result, then it returns the new value. So let's also go and quickly have a look at this. Public static void test3. The recommendation is that you always want to avoid using this kind of increment and decrement operators in complex expression. So only use plus plus and minus minus operators in simple single line codes. So you just want to quickly increment or decrement an operator, or x plus plus, x minus 1. You definitely don't want to, so don't do this. Don't say y equals, or for example int y equals plus plus x times 2 minus x minus minus plus 3. Don't do this kind of weird expressions. This is a valid expression, but it's very hard to understand if somebody just reads your code, right? Never do this. One of the very widely used way of these increments, these operators, is when you're dealing with arrays, right? So you can say that you are indexing into an array. So let's say you have an array and then you index it, but at the same time, when you retrieve a value from an index, you want to also move to the next index. So for example, you do this. And the way this works is that, as I mentioned, when you use index plus plus, so we're using a postfix notation. This eventually changes the value of the index parameter, right? If it's 10, it becomes 11, but it has a return value, and the return value is the old value. So array we'll look at the index at the current index, but then the index is incremented. So we're going to use look at the case 1, which is postfix notation. So int x1 is 5, int x2 is x1 plus plus. Now what do you think the value of x2 is going to be? X1 is going to be changed, right? Because we are doing plus plus, and this is an assignment operator. So the right hand side will be evaluated first, and the return value of the right hand side will be assigned to the left hand side. Postfix value notation has a return type which always returns the previous value of x1 in this case. So this expression gets evaluated, x1 becomes 6, but the return value is the previous value. So x2, this expression returns 5. So x2 becomes 5. So sysout x1, sysout x2. Let's run this. As you can see, x1 becomes 6 because that's the result of evaluating the right hand side. But then the return value of the right hand side is the old value, 5. That's why x2 is 5. You have to be careful about this. Now, for example, int x3 is that's why I don't recommend using compound expressions, especially if you do x2 minus minus plus x2, for example. That's something weird happens here, right? So what's going on here? You see, the assignment operator means you have to basically evaluate the right hand side first, and then assign the return value of the right hand side to the left hand side. So okay, so we have a binary operator, and for binary operators, first you have to evaluate the operands first, and the way operands are evaluated is from left to right for plus operator. So first we evaluate the left hand side of the plus operator, x2 minus minus. So let's see what happens. x2 minus x2 becomes we know that this minus minus has a return type. So when we evaluated, x2 becomes, right now x2 is 5, right? x2 becomes 4. But then the return value of this expression, x2 minus minus, because it's a postfix notation, it returns the old value. So when we go and remember, we evaluate this expression. So x2 becomes 4. But then this expression returns a value, which is the old value. So x3 becomes this returns the old value, which is 5. But then now, after evaluating the left hand side, we go and to evaluate the right hand side, which is x2 4, because x2, after the result of this expression, x2 is 4, but this expression x2 minus minus returned the old value 5, so x3 should be 9. Let's check this, x3, and we get 9. So be very careful how things work, right, with this postfix and prefix notations. Now obviously we can do exactly this, but we go with the prefix notation, and you can most likely guess what's going on. Prefix notation, these expressions also have a return value, but they return the new value, not the old value. So again, assignment operator, it has to evaluate the right hand side. It's a plus plus operator, which means eventually it increases the value of x1, right? x1 becomes 6, but this expression has a return value, and prefix notation returns the new value, so x2 becomes 6, right? And then now let's say minus minus x2. So we go and again, binary operator plus, we evaluate the left hand side first and then evaluate the right hand side. That's the order that these plus operators are defined in the Java language specification. So x2 now holds 6, the return value of this expression. And then when we say minus minus x2, obviously after evaluating this expression, regardless of whatever this minus minus x2 returns, remember the return value of this minus minus x2, the return value of the expression is not necessarily the current value, right? And we saw that that's the case for the postfix. But for prefix, obviously the return value and the updated value are the same. So in the prefix minus minus x2, after evaluating this expression, regardless of what the return value is, x2 will be 5 again, because here it became 6 and now it's 5. But then what is the return value of this expression? The return value is the updated value of the new value, which is 5. So x2 becomes 5, which means on the right hand side we have 5. But what is the return value of this expression? It's also 5. So we expect to get 10 here. Let's run this, and 10. So I hope you really have a great understanding of the prefix and postfix notation. Remember, in C++ you can overload these, and you have to be careful to not break the contract of the postfix and prefix. In Java, we don't really have an option to overload these plus plus or minus minus operators, neither postfix or prefix notation. And again, to reiterate, the contract of the postfix notation is that it updates the current value, right? If I say x1 plus plus, it's an expression, so it has to be evaluated, and when an expression is evaluated, it returns a value, and the return value of the expression doesn't have to be the same as its updated value. For example, in this case, x1 will be updated to 6, but this x1 plus plus as an expression has a return value, which is the old value of x1, which is 5, right? So be careful about these plus plus and minus minus operators. The increment decrement operators can be applied before prefix or after postfix the operand. The code result plus plus and plus plus result will both end in result being incremented by 1. The only difference is that the prefix version evaluates to an incremented value. What this means is that these expressions have a return value, which is the result of the evaluating the expression. And it says that the return value of this expression is the new value, whereas for the postfix, the return value of this expression is the previous value, or the original value, or the old value. If you are just performing a simple increment decrement, it doesn't really matter. That's why we always say that don't use complicated expressions with these postfix prefix, don't combine them. If you're just incrementing or decrementing a value, let's say you're saying that I plus plus or plus plus I, it doesn't matter. Why? Because in both cases the I will be incremented, but you're not using the return value of the expression. That's why it doesn't matter if you say I plus plus or plus plus I. Now, admittedly, if you go deep into the details, you realize that plus plus I is a little bit more efficient than I plus plus. Because again, I plus plus has to update the value of I, but return the old value. And in order to return the old value, it has to store the old value somewhere. Whereas for the plus plus I, it doesn't care about the old values, updates it and returns the new value. So plus plus I is always a little bit more efficient than I plus plus. That's why you see in for loops, for example, for int I equals 0, I less than 10, you see some people that have been writing programs for some time, they always prefer to use plus plus I. It's a style. It more at this point, I mean, these days the computers are fast enough so that it doesn't matter if you use I plus plus or plus plus I. The difference is so unnoticeable. But in terms of really, if you want to have the most efficient code, plus plus I is more efficient than I plus plus, because each time this expression gets evaluated, a temporary variable is created to store the old value, because you might assign you might want to use the old value, right, the return value of this expression. That's why some people prefer to use plus plus I for loops. Well, at this point, these days, it really doesn't matter. The difference is very insignificant. Just something that I want you to be aware of, that plus plus I is slightly more efficient than I plus plus, right? So I hope you enjoyed this lecture and have a very solid understanding of postfix and prefix notation for plus plus and minus minus operators. Please stay tuned and I'll see you in the next one.